Hello, my name is Darren Thomas, and I'm the Director of Educational Research Techniques. This is Simpler using machine learning algorithms in R, and we're now in Chapter 9. You can see here that we're going to be looking at how to assess the performance of a classification model, if you will, in this particular chapter. And you can also see that we have a few additional, we have a few additional lessons here, so it looks like we're going to have 6 lessons instead of the normal 4, but that's because we're dealing with a slightly different concept. We're dealing with how to determine how well your model is doing in terms of classification. That's obvious. And so, of course, we're going to start with an overview, which is what we're doing right now. I give you the big picture of what's happening. And then lessons 2, 3, and 4 are all about confusion matrices. We actually begin this lesson with a little introduction to confusion matrices as well. And this is one of the main tools that is used for assessing the performance of a classification model. A lot of the metrics are derived from the output that you will get from this confusion matrix. And so we're going to do, confusion matrix. What is it? We're going to do output and interpretation. We're going to look at the metrics, and then we're going to do something on visualization, the ROC curve, and lastly, we're going to take a look at cross-validation, which is something we've done before, but I want to focus a little bit more closely on it and make sure that things are clear in terms of that. So, having said that, why don't we go ahead and talk a little bit about overall model performance. And so I'm going to tell you a little bit about the confusion matrix. So, a confusion matrix is a matrix in general is when you're trying to compare categorical data with categorical data. One of the most common matrices that you can think of often is, when you use a table function in R, where it counts how many of this and that, and how you can set up several variables. But in general, a confusion matrix has these two. It's a box basically, and we've seen this box before. So it looks something like this. And so, and the box is divided into 4 regions. That's assuming that your categorical variable has 2 groups. If there's more than 2 groups, you'll probably have 6 boxes and not 4. And so across the top, you often have the predicted values up here. And then over here, you'll have the actual. And so what happens is that when the actual classes, that this is what you would get, for example, when you look at, we commonly use, test, $, and then class or something. That'll be what it is. And the predicted values will come when you use the predict function in R. So when the actual class and the predicted class from the predicted model agree, we call it a true positive. And generally they're in the upper left-hand corner like this. Now, when the actual class and the predicted class agree in the opposite direction, where they both agree that something is negative, we call it a true negative. That's down here in the lower right-hand corner. That's kind of how it works out. Now, sometimes there's a problem. Sometimes the actual class and the predicted class will disagree. And when that happens, it could be a false negative. In other words, the predicted class thinks that it's negative when it's not, or it could be a false positive. In other words, the predicted model thinks that it's positive when it's not. And so these 4 categories, these four types are the potential outputs that you will receive when you're doing a classification model. And the interesting thing about this is that with these 4 these 4 types of measures here, you could do a whole lot of different types of you could calculate a whole lot of metrics. F1, specificity, recall, precision, of course, accuracy, etc., etc. And we will talk more about these when we get into the actual development of models and using these things in an actual context. But what we're going to do now is that in the next video, we're going to move over to the actual development of a model, and we're going to look at the confusion matrix output, and then I will show you some details on the different metrics that can be used when you use these different numbers here. Or not numbers, but yeah, these different numbers that you can get from these things. And keep in mind that these are raw scores. So you might have 50 that are classified correctly. You might have 10 over here. Whatever. They're raw numbers, and these raw numbers are used to calculate many different metrics, as I've already mentioned several times. So if this is a little confusing, no pun intended, but in the next video we'll take a closer look at confusion matrices, and it'll help to enrich your understanding about what we're trying to do here. So in this video we took a look at confusion matrices, and we provided an overview of what's going to happen in this particular chapter. A confusion matrix is basically where you are trying to compare what your model predicted versus the actual classes. And through this overlap, when the models agree, so for example, when they agree, you get your true positives and you get your true negatives. However, as with most models, no model is perfect, and sometimes the predicted and the actual will disagree, and that's when you start to have your false negatives and your false positives. And through understanding these 4 pieces of raw data, these 4 summaries of the data, you can calculate many powerful metrics to help you to figure out how to adjust your model for better performance. So my name is Darren Thomas. I am the Director of Educational Research Techniques. This is Simpler, using machine learning algorithms in R. Take care.